Hello beautiful people. In today's video we are going to go through our homework number 4 for Math Foundations. This is going to be the Are You Ready packet for Chapter 7 to prepare us for our Chapter 7 exam. Let's go ahead and start with translating from English to math. Write the sentence as an inequality, do not solve. So we're just translating, we're not actually doing the algebra. Let's go ahead and start with circling some of our key terms. The quotient. Quotient means division of some number. Some number is a variable. Since we don't know what number that is, we're going to choose a letter. It doesn't matter what letter you choose. You can choose X. I'm going to choose M. And 7, so we know what 7 is. Now this right here is going to be your inequality. Is greater than or equal to. All of this right here has one translation. And is greater than or equal to is this symbol here. And then we have 6. Now, what I have right now on the paper is not your answer. You do need to write this out. Quotient means that you're going to be drawing a line. Some number is M. 7 is greater than or equal to the number 6. This is going to be your answer. Okay, moving on to the next one, 5. Now you have to be careful on this one. Notice there's no is. So let's first translate 5. More than, so more is a translation. More is plus. Than is also a translation, which means we're going to flip. Some number or a number, let's use a different variable. I'm going to use X. And then our inequality is always going to start with the word is. So is less than. And then we have the number 17, which is already translated for us. So I'm going to write this wrong, and then I am going to translate it correctly. 5 more than a number is less than 17. So this right here is wrong. This is wrong. This is not correct. And the reason it's not correct is because of this than. Than says that we need to switch the order of the 5 and the sum number. So we're going to cross this out. This is wrong, right? That's not correct. So the correct answer is going to be X plus 5 is less than 17. Moving on. The product. Product means multiplication of some number. I'll use, let's use Y. And 8 is less than, so remember, anytime you see the word is less than or equal to, and then we have 24. So even though you see it than here, this is not a switch, okay? No is, there is. The word is here. So is less than or equal to is this inequality. But if you don't have the word is, that means you have to translate more and then you have to translate than. All right, let's go ahead and write out what we have. The product. Let me go ahead and write this wrong and then I'll fix it for you. The product of some number and 8 is less than or equal to 24. Now this right here is incorrect. You would get a format error. Because whenever we have multiplication, whenever we have times, the number has to be in front of the variable. So this again is wrong. We want to make sure that whenever you have multiplication, you have the number, then the letter to show your times. No thinking bubble here. This is the answer. 7 less than some number. So 7. Let's go ahead and translate. Okay, there's no is here. Do you see how there's no is, no is? So that means we need to translate less. Less is minus. We need to translate than. Than is a switch. Then we have some number. Let's use, A. And then you do, yes, have is right here. So is greater than. It's going to be your inequality. And then we have negative 30. Okay, so let's write this wrong and then fix it. 7 minus a is greater than negative 30. That's wrong. Because of the word than, we have to switch the order. So we have some number minus 7 is greater than negative 30. This is your answer. Okay, moving on to number 2. Determine if negative 4 is a solution for the following inequalities. Do not solve for x. Okay, so these are not equations. This is not solving an inequality. First of all, it's not equations because there's no equals. Here, these are inequalities. But it's not asking you to solve the inequality. It's not asking you to solve for x. What it is asking you is you're going to take this value right here, and you're going to put in negative 4 anytime you see x. To do that, you're going to copy and open up 4x. So let's do 2 open minus 5 less than 3. Open divided by negative 2 is greater than or equal to negative 16. Open plus 8 is greater than 4. So for all of these, you're just going to open up, and then what you're going to do is you're going to put in your value for your x. And x, they told us the value of x was negative 4. So negative 4 here, here, and here. Be careful. This is not 4 minus or 2 minus 4. This actually says 2 times negative 4 minus 5 is less than 3. And now we're going to actually do the math. Same or different? Different. 2 times 4 is 8 minus 5. You're not changing any symbols. You're not doing same or different. Here, you're just checking, okay? You're asking if this is a true or false statement. So we get negative 8, so 8 minuses and 5 more minuses. That gives me a negative 13. Is negative 13 smaller than 3? This is going to be your English. And this right here, is negative 13 smaller than 3? Yes, this is true. This is not your answer, okay? Not the answer. The answer is going to be yes or no. Yes, it is a solution. No, it is not. So yes, x equals negative 4 is a solution. And that's because we got true. So yes, because true. Okay, let's go again. Now we have division. We have divided by. Same or different? Same. 4 divided by 2 is 2. Is 2 greater than or equal to negative 16? This is your English. 2 is bigger than negative 16. This is also true. Remember, that's not our answer, so we're going to cross that out. We're going to write our answer. Yes, x equals negative 4 is a solution. Negative 4 plus 8, these are counters here. So 8 minus 4 is 4. Is 4 bigger than 4? Again, this is your English. 4 is not bigger than 4. It's the same thing. 4 is 4. But is 4 greater than 4? No, this is false. And because it is false, we're going to write our answer as no. It's not a solution. Okay, moving on. Question number 3 is asking us to graph the following inequalities. So the easiest way to do this is translate this to English, and then from your English go ahead and translate that. So x is some number. Here we have is less than or equal, and then we have 8. Here's your smaller side, here's your bigger side. We're going to find 8. Here's 8. And we're going to determine if this is open or closed. Now, when you have this line underneath, right here, that means it's going to be closed at the number they give us. So since we have 8, we're going to close it on 8. And then we have to determine which side we're going to be pointing the arrow. Since some number is smaller, we're going to be pointing towards the smaller side. Okay, let's translate this again. -1 is less than some number. Okay, find -1. Determine if this is going to be open or closed. Notice how there's no line here. That means it's going to be open at -1. So don't shade it in, it's going to be open. And then we have to determine which one's smaller, which one's bigger. Since they're saying -1 is smaller, that means some number is going to be bigger. Moving on to number 5, let's translate that. Sorry, not number 5. C with 5. This one is greater than or equal to, and then X is some number. Again, determine if it's going to be open or closed, because I do see this line right here. This is going to be closed. So we're going to find the number 5 and we're going to close it. Here's 5. Here's an open. We're going to close it. 5 is bigger, so we want bigger 5. That means some number is going to be smaller. Okay, now we're going to be writing the inequality for the following graph. So this is going to be your important number, so whatever they give you. You want to identify if it's closed or open. So we got 2 opens here. And then the line that you see, that's going to be your sum number. So sum number, sum number, sum number. That arrow is your sum number. You want to indicate which one's your bigger and smaller side. So there's your smaller, here's your bigger, here's your bigger, here's your smaller, here's your smaller, here's your bigger. And so what you're going to do is you're going to read it in English and then write it out. So some number is bigger than 0. Some number is bigger, it's closed, so we put a line, or equal to 0. You can also do 0 is smaller. So you can do 0 is smaller or equal to some number. Either one. You don't have to give me both on the exam, just choose one. Some number is bigger. It's open, so no line, open. Then 4. Or you can say 4 is smaller than some number. Here we have some number is smaller than 2. It's open, so no line. Or you can say -2 is bigger than some number. Again, you don't have to give me both, just give me one. That is correct. Now we're at question number 5. Let's go ahead and solve. Solving means that you're going to be putting a dotted line and you're going to be circling your letter. Cover that letter. We're going to be removing that -4. This is a one-step inequality. Let's bring down P. We have here as counters, -6 and -4 is a -10. Now, when you're doing this, you do have to ask a question. Did I multiply or divide by a negative? If you did, in this step right here, then you have to flip the inequality, switch the sign. Since we did not, we only subtracted. We're going to take our inequality and we're going to copy it exactly how we see it. Now this right here is what you're going to be graphing. So -10 is less than or equal to some number. So let's find negative 10. Here it is. Negative 10 is less than, so negative 10 is smaller. That means some number is going to be bigger. Okay, let's do it again. Okay, dotted line for balance. Circle your letter, cover it. Let's go ahead and add 15 to both sides. Again, in this step, we are just doing counters. Bring down your R. And we have for counters negative 12 and positive 15. That gives us 3. Ask yourself the question, did I multiply or divide by a negative? So again, we're looking here. We did not multiply, divide by negative. All we did was add. So since no, you're going to copy down your inequality, keep it exactly the same. Bring down the R, bring down the 3. Again, it is asking us to graph, so we do need to translate. Some number is less than 3. No line underneath, so we're going to let me finish this, and then I realized I made a mistake on the other one. So no line, so this is going to be open. So let's find 3. 3 is bigger, so that means some number is smaller. Again, this is open. Let's go back to A here, 5A. I made a mistake. Notice here that we do have this line right here, and since we have this line, this should be closed. Please fix that. So let me go back in and close at negative 10. Again, please fix that. Okay, moving on to C. C is still a one step, and we're going to be taking this negative right here. Let me see if I can highlight it for you. We're going to be taking this negative 4, circle that, and we're going to be multiplying by negative 4 both sides. So what you end up having, here's your dotted line for balance. You have C over negative 4 times negative 4 on top, 1 times negative 4 on top. On one side, your goal is to remove, so the negative is gone, the 4 is gone, you're removing. Only C is left over, we're going to bring that down. On this side, our goal is to multiply times, same or different, different. 4 times 1 is 4. And again, don't forget, you have to ask yourself a question. Did I multiply or divide by a negative? Now, if you take a look at this question right here, this step, we actually did multiply by negative. So the answer to our question is yeah, we did. And because we did, when we bring this down, we need to make sure to flip the inequality. So this greater than symbol, when we drag it down, is now a less than symbol. We need to flip the sign. We get still a negative 4, we get still C, but now the inequality is different. Let's go ahead and graph that. Negative 4 is less than some number. Again, let's not make a mistake. No line underneath, that means this is going to be open. So I'm going to find a negative 4, open, so don't shade it. And then negative 4 is smaller, so that means some number is going to be bigger. Okay, moving on. Graph the following linear inequality in one variable. Make sure to shade the true region. Oh no! So there's a mistake here. Let's go ahead and fix the mistake. The mistake is I'm telling you that I'm giving you an inequality, and I actually gave you an equation. So the difference between an equation and an inequality is the symbol. An equation will have an equal sign. An inequality will not have an equal sign. So let's go ahead and change these. I'm going to go ahead and remove this equals. I'm going to go ahead and remove this equals. And let's make this one a less than, and let's make this one a greater than or equals to. There you go, that's better. Now this is a one variable inequality, one letter. There's no x's and y's, there's only y, and there's only x. So on y, you're going to find the number 3. You're going to pick up a ruler and you're going to graph a line crossing out, going through that number 3. Now you got to be careful because this is going to be open. We say this is going to be dashed or dotted. So when you are going through the number 3, you're not actually giving me a straight line. Sorry, you are giving me a straight line. You're not giving me a solid line. It's going to be with dashes. Same thing here. Find on the x-axis the number -5. Now this one is going to be closed, so it's going to be solid. So I'm going to cross out -5 now with a solid line. Now this is not the answer. You're not done, because what it's asking you to do is shade in the true region. So for both of these, you're going to have to do a testing point. And the testing point I highly recommend is 0, 0. So test point is going to be 0, 0 for both. Here's your x, here's your y. Now that we have our testing point, we are going to plug in for each one and determine, is this a solid or a dotted line? Let's go ahead and plug this in. We want y, so open up for y. Put in your y value of 0, and this right here, 0 is less than 3, is going to be your English test. Is 0 smaller than 3? No. 3 is bigger. So here's our testing point at 0, 0, and that ended up being false. 0 is not smaller than 3. So all of this region, we're going to write big word, capital, false. We're going to pick up our highlighter, and we're going to color in the true region. The other side of false is true. Okay, let's go again. Testing point 0, 0. This time we're opening up for x. 0 gets put in for your x value. Is 0 bigger than or equal to -5? Again, this one is true. So here's your testing point. And this testing point ended up being true, so I'm going to flip my paper over. That means the other side is false. And then all of this section is going to be true. Now you want these like highlighting parts to be very neat. Moving into Integrated Math 1, we will give you multiple equations, so there's going to be overlap, so you don't want it to be messy. Okay, moving on. Graph the following linear inequalities with 2 variables. Okay, so now we have 2 variables. 2 variables means that you're going to have 2 letters. Both an x and a y in each one. Make sure to shade in the true region. So again, just because you graphed it doesn't mean you're done. Okay. So when we take a look at these examples, 1, 2, and 3, so A, B, and C, notice that we are looking at standard form equations. Standard form is when you have an x and a y on the same side. For standard form, you're going to create a table for your x-intercept and your y-intercept. Again, notice we have x and y on the same side. That means we have standard form. Notice you have x and y on the same side. You have standard form. And again, with standard form, you're going to create a little table for your x-intercept and your y-intercept. Okay, let's go back up to A and start solving. Copy down your inequality. This is the same way that you would do an equation. I'm going to copy it down twice. We're going to eliminate the one we don't want. So we want x. We're going to remove y. This is gone. We got negative. You can put a -1 times x. This might be better for you. And then greater than 2. You're going to divide by -1, divide by -1. X is then greater than, oh, wait a minute. Hold up. Did we multiply or divide by a negative number? And we did. Yes, we did. So here, let me highlight that for you. We are dividing by -1. And because we are dividing by -1, when we write this down, we have to flip the inequality. 2 divided by -1 is -2. This here is not your answer, right? This is not your x-intercept. We're going to write it in a different format, -2, 0. This is what you're going to be graphing. But be careful, you do need to flip that inequality. All right, now we want y, so we're going to remove the x. X is gone. Bring down the positive, so you want to take the symbol 2. +2, y greater than 2. Divide by +2, divide by +2. Y is greater than 2 divided by 2 is 1. Now, we did not multiply or divide by a negative number here. Here, we divided by a positive. So we do not flip the sign. So sometimes it's better for you to take the symbol, like even if it's a plus, go ahead and write down the plus so that way you know that when to switch the symbol and which not to. So that means we have 0, +1. Let's go ahead and fix that format error and put parentheses around here. All right, so we're finding -2 and 0. We're finding 0 and 1. Now you can use these 2 points and that's enough, and you can use a ruler, or you're going to count slopes. So up 1, 2, up 1, 2, up 1, 2, up 1, 2, up 1, 2. Down 1, 2. And the reason I'm doing this counting slope is to give me more lines, to give me more points so I can create a better line. Before we graph, we do need to determine is this going to be open or closed. This is going to be open, so that means we're going to be dashed. Make sure you have arrows even if it's dashed. Okay, one last step is to test for our true region. So we're going to find 0, 0. That's going to be our testing point. And you can do this anywhere you would like. I'm going to do that here. Open for x, be careful of the negative. Open for y is greater than 2. Now whenever you are testing your points, don't change this symbol. The solving changes the symbols when you ask this question. But when you're testing a point, do not change your symbol. So we get -0 plus 0 is greater than 2. So is 0 bigger than 2? No, this is false. So that means all of this section is false. And our true region is going to be here. moving on to the next one. Same thing, copy and paste. We have negative 9x plus 3y is greater or equal to 3. Negative 9x plus 3y is greater or equal to 3. We are wanting x, so let's go ahead and remove our y. Y is gone. Bring down the negative 9 times x is greater or equal to 3. Divide by negative 9, divide by negative 9. Okay, be careful here. Let's go ahead and highlight this. This right here is a negative division. Let's see if you guys can see that. I don't think you can see that. This is a negative division. Now be careful on this one. This is not going to be a pretty number. Let's bring down x. Same or different? Different. 3 is on top, it's smaller. 9 is bigger. So that means 3 goes into 3 one time. 9 and 3 is a 3. Now, be careful. I put an equals here. That's wrong. Be careful here because it's not going to be a pretty number. This is 1/3, so we're going to have to guesstimate where that is. Just continue watching it and I'll show you what to do. Here, did we multiply or divide by a negative number? Yeah, we did. This is negative 9. So this inequality symbol, when we drag it down, needs to be flipped to the other side. So we got a less than or equal to. Thinking bubble, because this is not our x-intercept. X-intercept is a point, so we got negative 1/3, comma, 0. Close it and open it. Okay, for our y, we want to get rid of x. We don't want x, so that's gone. Bring down with the symbol, so we want to take the plus 2. Plus 3 times y is greater or equal to 3. Divide by a positive 3, divide by a positive 3. This is why taking the symbol is important, because then you can ask yourselves, did I multiply or divide by a negative number? No, we did divide, but this division was a positive division. Okay, bring down the y, symbol stays the same. 3 divided by 3, both positive, is 1. Thinking bubble for the correct format of 0, 1. Okay, so how do we graph this 1/3? To the best of our ability. We are on the negative. 1/3 is going to be somewhere really close here, not touching the 1. Okay, so if I try to zoom in, I don't know if the camera is going to let me. The camera does show, so let me even make it a little bit smaller. So right over here, here's negative 1. We don't have a negative 1, we have a negative 1/3. So that's smaller than 1 whole. So you got to put your point somewhere here really close to 0, but it's not 0. And then for y, we have a positive 1, like this. You cannot really count slope because the 1/3 is not pretty. So we're going to have to deal with the fact that these are going to be an approximation. Before you graph, let's go ahead and say if this is going to be open or closed. This is going to be closed because of that line, which means we're going to be solid. Bring up your ruler, connect to the best of your ability, and it's going to be something like this. Again, we're going to try our best. This may not be fully accurate on the slope, but again, we're trying our best. Now we still need a testing point. Testing point here for 0, 0 can still be used. It's pretty close, but we can still be used. Besides, testing point of 0, 0 is going to be your easiest choice. Here's your x, here's your y. Copy down, so negative 9, open, 0, close it, plus 3, open, 0, close it, greater than or equal to 3. We got 0 plus 0 greater than 3. Is 0 bigger than or equal to 3? No, this is false. So all of this is going to be false. That means our true region is going to be on top. Let's go ahead and move on to C. Again, this should become a little bit repetitive now. It's the same thing over and over and over. Let's go ahead and copy down our inequality. And we have 5x plus 10y is less than 40. For x, we want to keep x, so let's remove y. That's gone. Bring down the 5 times x, less than 40. Divide by 5, divide by 5. And you have to ask yourselves, did I multiply or divide by a negative number? So we are dividing, yes, that is true, but we are dividing by a positive 5. So when we bring down our inequality, we are not going to change it this time. We're going to keep it the same. 40 divided by 5. Use your multiplication table for that. And we have 8. Thinking bubble. That means we have 8, 0. For our y-intercept, we do not want x. X is gone. Bring down the plus 10 times y. Divided by a positive 10, divided by positive 10. Again, did I multiply or divide by a negative number? No, this is a positive division. So that means when we bring down y, we're going to keep the inequality. 40 divided by 10, again, use your multiplication table, and that is 4. Correct format is 0, 4. Let's go ahead and graph. 8 on the x, here's 8, 4 on the y, and then you have to determine, is this going to be open or is this going to be closed? And because it doesn't have that line underneath, we are going to be dashed or opened. Again, we can try to count slope. This is a pretty big difference. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So I was able to create one more point to help me with my dash line. Let's bring our ruler. Dashes. Make sure you have arrows. If you do not have arrows, it would be marked as incorrect. And then again, here's our testing point. We're going to do our testing point one more time. Testing point 5 open plus 10 open less than 40. Put in 0 and 0 for your testing point of 0, 0. So we got 0 plus 10. Just kidding, that's wrong. 0 plus 0 is less than 40. Is 0 smaller than 40? Yeah. That is true. So that means the other side is false. And we're going to color in the true region. Okay, moving on. Question number 8. Okay, question number 8 is exactly the same question. Graph the following linear inequality. Reminder, I think it says systems. That shouldn't say systems. So we just have graph the following linear inequality. Systems is something you're going to do in integrated math 1. Reminder, make sure to shade in the true region. Now, the difference between here and here, 7 and 8, is we have x and y on the same side for standard form. Here, we do not have x and y on the same side. So if we do a dotted line, we're not solving. I just want to show you. We have y on this side, we have x on this side, which means this is in slope, intercept form. When you have y alone on the other side, that means you have y equals mx plus b. Now for us, we don't have an equals, right? Because we have an inequality. So we don't have an equals. But what we're going to do is we're going to identify what our slope and our intercepts are. Ignore the y. This right here is your slope. Yes, it is just a negative, so that means we have negative 1 over 1. And since we have negative, that means we're going to go down 1 and 1 to the right. For your y-intercept, you're going to pick up the positive 2, and you're going to write it as 0, comma, positive 2 for your starting point on the y-axis. Then you're going to take a look and see, do we have an open or closed, solid or dotted? This right here is going to be open, which means it's going to be dashed. And let's start. So we're starting at 2. Here's 2. We're going to go down 1 and 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. And you keep going until you run out of space. With slope-intercept form, you want to give as many points as you can because you do know the slope and you want to make sure your line is really accurate. There you go. And so we're going to pick up a ruler and start connecting with dashes. Okay, where's my pencil? There it is, and dash. Okay, dashes. We still need to do our testing point. Testing point, again, you want to choose 0, 0. For testing point 0, 0, let's go ahead and copy down our y less than negative x plus 2. Put in your x and y, so 0, 0. 0 is less than negative 0 plus 2. 0 plus 2 is just 2. So is 0 smaller than 2? Is 0 less than 2? Yes, this is true. So that means the other side is going to be false. And this side is our true side. Okay, let's do that 2 more times. Okay, let's start by identifying your slope. Notice that is a positive 2, so I'm going to put a 1. Since it is positive, we're going to go up 2 and then 1 to the right. Identifying your y-intercept. Remember to take the symbol, so it's 0, comma, negative 3. This 0, negative 3 is going to be your starting point on the y-axis, using your slope to find the other points. So we're going to go up 2, 1, 2, 1 to the right. Up 2, 1 to the right, 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 up 2, 1 to the right. Down 2, and to the left. Okay? And then again, before you do any connecting, you got to determine if this is going to be solid, dotted, dashed, or closed. So we got no line, so that means this is going to be open, which means it's going to be dashed. Bringing our ruler, connecting with dashes. Okay, again, you're not done. You got to determine which one's the true region. So here's our testing point, 0, 0. Label it x and y. And let's go ahead and copy down our inequality. Y is greater than 2x minus 3. Open for y, open for x, put in 0 and 0. So 0 times 2 is 0 minus 3. So we're going to, I don't have space, I'm going to do it here. Is 0 greater than negative 3? Yeah, this is true. So that means testing point is true. This other region is going to be false. And we're going to color in the true region. Okay, doing this one more time for C. Here's your slope. Remember, it's positive. So that means up and to the right. And your y-intercept is 0, comma, negative 5, which means we're going to start on the y-axis at all the way negative 5. For our slope, we are going up 1, 2 to the right, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2. Okay, and then we're going to follow that same pattern to the other side. determine if this is going to be open or closed. Now if you take a look here, we do have this line, and because we have this line, it's going to be closed, which means it's going to be a solid line. Get your ruler, connect. Now this time we are connecting a solid, so no dashes. And then let's go ahead and do our testing point of 0, 0. Okay, testing point 0, 0. Let's copy down our inequality. Y is less than or equal to 1/2. Oops, we don't have to open in this step. We're just copying it down. X minus 5. Y is less than, just kidding, this is where we're going to open. 0 is less than or equal to 1/2. 0 minus 5. This is why we want to use 0 as a testing point, because no matter what it's touching, it's going to be 0. And then 0 minus 5 is negative 5. And then be careful, here is 0 smaller than negative 5. So if we use a number line, here's 0, here's negative 5. Notice 0 is bigger, negative 5 is smaller. So this is actually false. So we're going to color in our true region.